everyone, this is Hermione.
And I'm Bruna.
Welcome to another experiment of physics and how its principles link to life science. The purpose of today's experiment is to demonstrate Newton's first law of motion.
The first law of motion says that an object at rest stay at rest and an object in motion stay in motion with the same speed and the same direction unless acted up by an unbalanced force.
So, imagine you're running a 100 meters race and somebody asks you to stop suddenly. Will you be able to stop? The answer is no. You can stop, but gradually. This is the same story with every object.
Like the ball here, it is at rest. It will be at rest until a force makes move. So for the experiment today, you're going to be using a glass, a card, and some coins. The experiment, it is really easy. You can do anywhere, and there is no really precautions or dangers in it. Just be mindful to not hurt yourself with anything. On the top of the glass, you put the white paper or any paper card, and you put the coin on top of the card. And you just pull the card out, and the coin will drop inside of the glass. The coin is going to be at rest unless a force is applied to it. But because you're going to use a force in the paper, the coin is going to stay in place. But gravity is going to exert a force and drop the coin in the glass.
So Newton's first law can be observed everywhere, whether it's in the wild, in the nature, or all around us. For example, an apple sitting on a tree would be at rest unless acted upon by an external force, like the bear in this case. A bear may knock off the tree in order to obtain food. The apple will fall to the ground, roll before coming to a pause. The law of inertia, or Newton's first law, applies in this case. The apple was at rest, but because of the external force by the bear, it fell down to the ground. Another example is a gazelle running away from a cheetah. The gazelle does a quick leap sideways. However, the cheetah can't turn quick enough. The law of inertia applies in this case as it keeps it going in its original motion, and the gazelle escapes.
That's all from us today. See you next week.
For another experiment showing Newton's second law of motion this time. Thank you.
Bye.